Hi everyone. So today we're going to work on what is called logarithmic functions. So we're going to work on this. We better define what it is so that we can understand what we're going to do. Okay, so a logarithm is going to be defined as base b of a positive number x satisfies the following definition. So it's not really a definition, it's more like a relationship. So for our base b, which has to be greater than 0, can't be 1, that we're going to have log base b of x. Okay, so let's just stop equals y. Okay, so let's just stop there for a moment. So we have this short word log, which is basically shorthand for logarithm. We have a subscript, which is called b. Okay, so there's our base. So it's a subscript of x is equal to something called y. Well, what's x and what's y? Okay, if and only if b to the y is equal to x. Okay, so looks like there's a relationship between a logarithm and an exponent. So that means if we look at it closely, that our base to some power is equal to the answer. We go log base answer equals exponent, which means that the answer to a logarithm is an exponent. Now, why do we care? These two are inverses of each other, meaning we're going to switch x and y and solve for y. So when we do that, we end up with x in the exponent. We get something in the exponent, and how are we going to solve for that? That's what we call a logarithm. So a logarithm is the inverse of an exponent. And what we're going to do is it answers the question, what exponent gives me this number? Okay, if something's being taken to a power, what power is that? All right, so if I'm over here, let's do a real short example. Okay, so we know 4 squared is equal to 16. All right, so we're going to write that as a logarithm. We're going to go log base 4 of 16 is equal to 2. So we notice that our answer to the logarithm is the exponent. Okay, so that's important because if I want to know how long or what time it takes me to get so much money, or we do some applications, that's key. So remember that a logarithm is just an inverse of an exponent, which means my domain and range are switched, that x and y are switched, order pairs are switched. All right, so let's try and write these exponents as logarithms. So we have 9 squared equals 81. So we're going to go log base 9 of 81 is equal to 2. Okay, so it doesn't matter what the base is. So here we have log base 1/4 of 1 over 64 is equal to 3, meaning 3 1/4 to the third power gives me 1 over 64. Okay. So here we have log base 8 of 512 is equal to 3. All right, so why don't you pause the video for a second and see if you can do the rest of them. All right, let's see if I get this if you get the same answer as I did. Log base 1/3 of 9 is equal to -2. Log base 10 of 0.001 is equal to -3. And log base 4 of 1024 is equal to 5. So hopefully you got those answers. And again, the relationship between an exponential function and a logarithmic function is that they are inverses of each other. All right, let's go the other way. We're in log form, and we want to write in exponent form. All right, so the easiest way I can tell you to do this, guys, is if I go 2 to the 5th equals 32. 4 to the 4th is equal to 256. 3 to the 8th is equal to 6,561. All right, why don't you pause the video and try this one? Try the next couple. 2 to negative 10. And we'll see if we all get the same answer. All right, so hopefully you got the same answers as I did. All right, now, the hard part is coming up with the answer to a logarithm, like what is the exponent that gave us this? So there's a couple of different ways you can look at it. Unfortunately, our calculator does not do some very basic. Log is on our calculator, but it does not have a base. All right. By the way, I'm going to send you a link to a new video or new calculator that you can download on your iPad. So when you're evaluating, the question is, you should ask or write it in exponential form. Is 2 to what power gives you 16? Okay? So 2 squared is 4, and then you have 3 is 8, 4 is 16. So our question mark here is 4. Okay. So 4 to what power gives you 64? Okay, I believe that's 3. 5 to what power gives you 125? I believe that is 3 as well. Okay, now we are going to learn a better method than just guess and check here. So right now, I just want you to get comfortable. So 10 to what power gives you 100,000? I believe that's 5. I'm very good at those. Yep. All right, let's try this. 4 to what power gives you 2? Uh-oh. How are we going to figure that out? Well, isn't 2 the square root of 4? And don't we have to raise that to the, isn't written as a power 1/2? There we go. Okay, so 27 to the some odd power is equal to 81. Now, I don't know the relationship with this, but I do know that both of these are powers of 3. So I can change this to 3 to the 3x equals 3 to the 4th. And since the bases are the same, we can set these exponents equal to each other. Okay, so is the cube root of 27, which is 4, taken to the, or 3, which taken to the 4th power, is that 81? And the answer is yes. So when you're struggling and there's no relationship, try getting the bases to be the same and use your power to a power property. So for example, in this one, we know 64 to what power gives us 32? Okay, I'm going to make that an x. Okay, so I noticed that I don't see a relationship here, but I do know that these are powers of 2. So 64 is 2 to the 5th. Oh, no, 2 to the 6th, excuse me. And 32 is 2 to the 5th. So now I'm going to do 6x is equal to 5. X is equal to 5/6. Okay. All right, so try and get them to be the same base and then set the exponents equal to each other. So a lot of this is going to be guess and check, guys, because we don't know these off the top of our heads. So we want to know 4 to what power is 32? Again, let's make them both base 2. So I'm going to go 2x is equal to 5. X is 5/2. So again, key is I would write these as exponents when I'm solving and either try guess and check right now, get the bases to be the same, and set the exponents equal to each other. Now, one more thing before we're done is that there's something called a common log. So a common log is a logarithm whose base is 10. And that's not something, we usually don't write base 10 when we're dealing with it. So common log is a logarithm whose base is 10. Okay, so it's called common because that's the one that's used most often. It's the one on our graphing calculators because they don't have other bases that we're going to use. So this is the one that's most common. This is the one we're going to use when we're trying to solve, and things like this when we can't figure out the relationship. So what you're going to see is instead of writing log base 10, let's say of 100 is equal to 2, we're going to see it as log 100 is equal to 2. So notice there's, over here I have the subscript 10 that's not over here. It's understood to be 10 if there is nothing there. And everything else is the same. We would write it as an exponent. We would, like 10 to what power gives me 100. All of that stays the same. All right, that's it for today, guys. Let me know if you have any questions. And remember, staying in keeps everybody safe. Have a great day.